All right. Well, welcome. Hello. Welcome to today's webinar, highlighting PhET simulations for early math. Today, we're going to introduce you to 3 PhET simulations designed to engage and empower early math learners as they build number sense and create some counting strategies. Thank you so much for joining us from wherever you are. My name is Catherine Carter, and I joined PhET, the team of PhET, last summer after 20 years of teaching as a high school math teacher. During those 20 years, I also spent 10 years facilitating kindergarten through 12th grade professional development. And I came to PhET because PhET offers a unique perspective of helping students really learn hard concepts through play. So I hope you'll enjoy today's webinar and you get a chance to share my joy of providing opportunities for students to really develop their own love of math. So I'd like to introduce my colleague, Amanda McGarry. She's going to be monitoring the chat and the Q&A.
Hi, yep, thanks everyone for being here. I'm Amanda, and I've been at PhET for over 9 years. Before that, I was a high school math teacher, but I've also worked on the design of many of the math sims, including the ones you're going to see today. And I look forward to learning how you all see the utility of these sims in this webinar. And Kathy and I are joining from Colorado, just to add to what we're seeing in the chat.
Yep. We're lucky in that PhET is based out of University of Colorado in Boulder, so we're both local PhET folks. So today's agenda, what we're going to do is first learn what a PhET simulation is. You may or may not have heard of PhET before, and a lot of teachers have not. PhET has typically been well known in the secondary science community. So thank you for joining us, even if you didn't know anything about us. Today, we're going to engage with 3 PhET simulations that are specifically geared towards the early math and help you get a sense of how a lesson can support the PhET sim and leverage the power of the sim. We're going to explore one lesson per sim. We're going to conclude with a summary and then definitely take some questions if you have them. And without further ado, if you do have a question, we encourage you to use the Q&A, that button across the bottom of your screen. If you do want to speak your question rather than typing it, feel free to raise your hand. And when you do, we can give you permission to unmute and then you can ask your question live. So we do encourage you to do that as well. The chat is always an option. Just please remember that sometimes questions get lost in the chat. And so if you do have a question, we encourage you to use the Q&A. So first, what are PhET interactive simulations? PhET simulations are highly interactive tools that really elevate challenging concepts that you can leverage in your classrooms. PhET was started in 2002 by Carl Wyman, who at that time was a Nobel laureate winner, and he used some of his prize money to start this project. It first started with only physics. That's what PhET stands for, is physics education technology. But now, since then, in the 20 years that we've been open for business, there are physics, chemistry, math, earth science, and biology sims, all free. So all of our resources, open education resources, are free. All of our simulations are free. All of our resources on our website are free. And so we hope that you find something useful today that you can use for free. On our website are over 3,000 activities, mostly teacher submitted from our very large teacher community, helping others learn how they can also leverage the power of the Sims. Our Sims are translated into over 100 languages. It can run online or offline, and I'll show you how you can run the Sims offline later on. Our Sims are research-based, meaning we look to the research for inspiration on what students are struggling with, in addition to our own experience as educators and our pedagogical experts, such as yourselves, and university professors and people in the community. We create very intentional learning goals. And to make sure that our learning goals are being hit, we do conduct interviews with both students and teachers, sometimes in the classroom, to make sure that our learning goals are being hit. This is an iterative process. So if something isn't working, we will go back to the drawing board and perhaps redo some components of the sim. And it takes about a year from idea to publication when we're creating a simulation. If you do a Google Scholar search for PhET, Over 71,000 articles show up. So you can see how we both contribute to the research base as well as draw from the research base. I'll show two examples of the research that's out there. This study was done in a fourth grade classroom in October before the fourth graders had learned any fractions whatsoever. Students in the last week of October took a pretest to assess their procedural and conceptual knowledge of fractions. The following week, there were only 4 20 to 30-minute lessons given to these students that used the PhET simulations based in fractions. No other interventions were utilized in the classroom by researchers or the teachers. And after just 4 lessons of 20 to 30 minutes using the PhET sims, you can see with the green bars that their scores in both procedural and conceptual knowledge increase greatly. The Sims not only can increase knowledge, but can also change the discourse of your classroom. In this study, this was the same teacher. The researchers observed a teacher teaching a lesson with both a simulation and a non-simulation. And what the researchers found was that when the same teacher was using a lesson without a sim, the lesson pretty much focused on practicing standard procedures, recalling facts, appealing to the rules, but when the same teacher used a simulation, a shift in the discourse occurred. The students were exploring new math ideas, they were inventing their own strategies, they were collaborating without being told to. And so the discourse and the knowledge base can change when simulations are used in the classroom. So without further ado, we shall play with one. The best way for you to see for yourself is to play. This is the first of the 3 simulations that we're going to highlight today, number play. Amanda is going to put the link for number play in the chat. And as you play, your job is to discover as many features as you possibly can. And think about how students might interact with a sim. How does a sim help build number sense? How might you use it? But the goal is for you to discover features. So I'm going to pause for 3 minutes or so as you discover. And as you do discover, we encourage you to enter in your discoveries into the chat. So in 3 or so minutes, I will call you back to enter your discoveries in the chat. So now that you've played for 2 minutes or so, as you are ready, go ahead and enter in some of your discoveries of what the sim can do in the chat. And then the goal is that we help each other learn things we may not have found. So as you're entering them, I'll model what you're finding and probably more. There's a lot in the sim you may or may not find. Great. So the first discovery that I will model is that somebody noticed that as you pull objects out into the play area, we can organize them using the 10 frame. Or you can see the 10 frame here, multiple representations of the 10 and the 20. Yep. Subitizing game is fantastic. Agreed. We'll show that as well. Notice that you can organize these play areas independently of each other. Maybe a couple more and I'll highlight some more features. Spoken option.
4,
Mhm. Okay, so I'll share some other things that you may or may not have found. Okay, Brian has a question. Let's see. Go ahead, Brian. You can unmute yourself or I can unmute you.
Is the language feature just English when it's spoken?
No, and I'm so glad you asked. This is a very important feature. So as you asked, I will feature or model that for you. So I'm going to go ahead and lower your hand. And then Amanda, can you do the rest? So some of you may or may not have noticed that there's a settings or a preferences menu down here. The settings cog is down here. One of the coolest things is that in this simulation, you can actually turn on a second language. So as I go to the second language, I can turn this on and I get some options. This is English plus another one. Notice you can also change the subitized time. Some of you found the subitizing in the game, and you can show the ones or not show the ones on the lab screen, which I'll also model for you. So I would say that maybe one of the more common languages is Spanish from Mexico. So if I click this,
1, 2, 3.
you notice we have some choices of the speaker.
1, 2, 3.
So you can choose the voice, you can choose your second language. And after you choose that, now there's an extra toggle here, English and this. So after I press this toggle, now not only is the number written in Spanish,
4,
but you can also hear it in Spanish as well. Thank you so much for asking that question. I will model the lab, yeah, for sure. So let's see, student choice of counting objects, drag items, practice 1-to-1, all the different ways to represent the numbers. Doesn't matter which window you change the number, it changes all of them. Yes, so here, what you're all noticing is that this is absolutely highlighting and stressing the importance of the 1-to-1 correspondence. I can pull an object from the right, I can change the context if I so choose. I can pull a puppy, I can pull a number, or I can drag it from either of these panels. I can also drag it from up here. So there are multiple ways that you can control the number of objects that are in here. So one of the other features, this is one that you may or may not have found, is that I can count them and actually combine these numbers in a way that can't happen on real paper. So 1 and 1 is 2, and this turns into a 2. 2 and 1 is 3, and another one makes 4. Now I have these matching, and now I have these puppies over here that match the number that I have here. I can compose and decompose numbers as I wish. In the game, you may have found that these two show the object in a multitude of varieties. If you get it wrong, that's okay. What happens is this goes gray, so the students eventually will be right. Or they might be not arranged at all. These are still movable if the students want to practice organizing in a 10 frame, or maybe organizing in any way that they find is useful. You can move these around. The subitize is essentially similar, except for the subitize level 1 goes 1 to 5 and level 2 goes 6 to 10. Notice that you can change the subitize time in the settings. And I can also, if I missed it, I can look again, and then I can choose my the number of objects. For the lab screen, this is essentially an interactive whiteboard. So this is the only screen that does not provide feedback for the students. This is a great way to offer opportunities for students to be very creative in their thinking, but do know that it does not give them feedback. You may have noticed in the 10 frame, I can't combine objects. And that's to reinforce the idea of the unit. The unit here is a puppy, and I can't combine the object because that's not a puppy. So there are very intentional built-in constraints to the sim to help reinforce some of the math concepts that are hidden in the early math. Okay, so what we're going to do from here is that we're going to go through, well, first, I forgot about this slide. These sims are highly interactive. What you notice is that there's an intuitive interface. Notice there are no instructions on the screen. Most of our sims do not have instructions. Most of our sims just invite the students to just play, and we consider all play as productive play, where the students are just invited to touch things, and by doing so, they start learning about the important concepts that are very challenging. Pedagogically powerful actions, where, for example, you can combine 1 and 1 to make 2 that you cannot do in real life. We have multiple accurate dynamic representations, and I will say that I don't know if you've heard yet, but there is a plug for data fluency and data science in kindergarten through 12th grade, working its way into the standards. It's a good thing. And so one of the characteristics embedded within data science and data fluency is being able to model data in multiple ways. So all of these different representations fulfill a characteristic of the data fluency and the data science. We also have what's called implicit scaffolding. We have a sense of where students will begin, and then the implicit scaffolding is an implied increase in cognitive difficulty. For example, 10 goes to 20, and then the game is testing their knowledge. So we implicitly scaffold these sims to encourage students to build that level of complexity naturally. So the first lesson, as I said, we're going to highlight 3 lessons for these sims. The first one is called Family of Mr. 10. At the end of this presentation, I'll show you, just so that they're all in the same place at the same time, I'll show you how you can find this lesson and many more on our website. And so each of the lessons might highlight a different aspect and really help you know how to engage and leverage the power of the sim and the functionality of it. In this lesson highlights cardinality, conservation of cardinality, one-to-one correspondence, and of course, the commutative property. So what I'm going to do is I'm going to model for you how you might interact with the lesson. And of course, you can modify it on our website. Not only is there usually a PDF, but there's a Word version allowing you to modify as you need. So the way that this lesson works is that you would pull 10 objects. Right now I'm using the 10 screen. You could use the 10 or the 20. I will use the 10 so that the number of objects maxes out at 10. We do know that there is a standard specifically focused on 10 and decomposing 10 for the reason that it's important in place value. And as you're working through this lesson, I would encourage you to keep this side disorganized as you at least verify first that we have 10. So there are multiple ways you can verify that you have 10. You can verify with a number, as we mentioned before. We can verify with the 10 frame. We can verify with a number in one of 2 languages that we have 10. I can also combine these and count as we go. So you may have to do this a few times with your students to convince them that there really are 10. But we would have 2, 3, 4, 5, 6, 7, 8, 9, 10. Notice that the objects over here didn't change. So if we had 10 objects before, we still have 10 objects, highlighting conservation of cardinality. I can decompose this 10 into, say, 9 and 1. As you do this, I encourage you to ask your students, how many puppies would be in a group? If I had to have 2 groups of puppies, how many different ways or in what ways could I break this group of puppies into 2 specific groups? How many puppies would be in this group? How many puppies would be in this group? As I take one away from 9 and put it over here, again, ask how many puppies would be in this group and how many puppies would be in this group. And you can do this as many times as you like. You could go all the way down to 1 and 9. You could reinforce the commutative property. What you're going to want to do after you do this is, after you establish that this is still 10, the only thing changing are these numbers here. These buttons over here provide a powerful connection to the one-to-one. When I press this middle button, I'm not sure if you found this feature, but when you press this middle button, these puppies turn into cards. I can say, okay, I have 7 puppies on this card. So I have 1, 2, 3, 4, 5, 6, 7. And then I have 3 puppies in this group. 1, 2, 3. Now, it may not be obvious that these are actually a one-to-one correspondence. So at this point, or at some point when your students are ready, you can use this lock button. The lock button mimics what's happening on one side and the other, really powerfully reinforcing conservation of cardinality for the number 10. If I moved a puppy from this group into this group, how many puppies would then be in this group? And how many would be in this group? You can physically watch one of the puppies moving, and with the lock on, I can see now that there are 6 here and 4 here. Hopefully you notice that you can collapse these. If you didn't want your students to see that number 10, you could close it and engage with the sim as you see fit. At this point, you can invite your students to be creative. What other ways can we decompose 10? How many other ways can we break up these 10 puppies into 2 groups, reinforcing all of the important aspects of one-to-one correspondence, conservation of cardinality, that 10 can be decomposed in many ways, that they can come in pairs. And of course, this logic could be applied to any number. Are there any questions or anything that needs to be addressed before we move to the next sim? This is like a crash course in our simulations, so I encourage you to play with them on your own as we're going through them kind of quickly. Okay, so then as we go to our next simulation called Number Compare, Number Compare is a sister sim to Number Play, where it isolates the comparison of the numbers. You'll see a lot of the same features. Amanda put the link to Number Compare in the chat. And once again, I encourage you to play with a few minutes to discover some of the similarities and differences between Number Play and Number Compare. As you find them, feel free to type them in the chat, and then we'll model them as we see some come in. So there's a question in the chat about, do they work with screen readers? And Amanda pointed out there are several sims that do work with screen readers. I don't think these particular ones do, but I can show you how to find the ones that do. Yeah, when we look through the website, show you how to filter by that feature. As you then have discoveries about similarities and differences, feel free to put those in the chat, and then we can model some of those features. Perhaps some of the differences specifically, as we have seen some of the similarities. So this inequality statement is below to reinforce the meaning of the inequality. Mhm. And you can also turn it on and off if your students aren't ready for it. If your students aren't ready for it, in our interviews doing this, when we were interviewing with this simulation, we noticed some students were trying to connect the symbol with addition or subtraction. So sometimes the students just aren't quite ready for that symbol. So you can definitely toggle that off or on. Perhaps a few more observations. Mhm. So I'm seeing some things that are new in this sim that are different from number play. Number play and number compare, as I said, our sister sims have a lot of the same functionality. And some of you are noticing that there's a representation here in the middle, and that representation can change from, say, a bar graph to a number line or nothing at all. If you don't want anything, you can change the representation of how you're showing a statistical concept of the graph or the number line. So the lesson that we're going to go through today is called Comparing Using a Vertical Number Line. Some of you notice that there is that vertical number line. I will show you later how you can customize the sim and change the maximum number on this number line that you can have so that it doesn't always have to be at 20 if you don't want to overwhelm your students. This lesson really highlights one-to-one correspondence and making sense of that vertical number line. Vertical number lines are used in, say, temperature gauges and a lot of other places. So I don't think this is a very unfamiliar concept for children, but they may or may not have any idea how to read it or use it. So that's what this lesson is really trying to elevate, is how to use and really bring out that number line. So the way that this lesson would go is, first, if you didn't notice, this orange button here is a reset all button. It will reset the sim back to its default state except for the settings. So whatever settings you have, if you have a second language turned on, for example.
1, 2, 3.
So if you have another language, it does show up a little differently than in number play, but it still has the same impact of changing the words to that language and speaking it
0 ist gleich 0.
in English.
0 is equal to 0.
Similar to number play. So in this sim, if I hit reset all, notice that anything in the settings does remain. So this lesson starts, and I'm going to turn this off because one of the goals of this lesson is to really make a one-to-one correspondence with the graph in the middle and the number of objects on each side. So perhaps you notice that this sim is different. If I pull 4 puppies out on this side, nothing happens over here. In the number play, we had a one-to-one correspondence between the two play areas. But because this sim is about comparing, I can have different objects. I can have different representations, different number of objects. And if I want to have the ones, I have to intentionally choose them in this particular setting. So notice also that the default is the cards, which in number play is this middle button right here. So the default is the cards so that you can combine them and compose and decompose that way. So this lesson will ask students to say which side has a greater number of objects. If you wanted to really challenge your students, which we always encourage you to do, appropriately, of course, is to ask, what number could I put over here so that there aren't as many objects as are over here? That opens up some other possibilities rather than just you putting some objects there and saying which one is bigger. Either way, however you decide to do this, we can say, how do you know which side is bigger? And as you're creating many different types of situations and asking, how do you know which side has a larger number of objects in it? Then you start asking the question, how many orange squares are there? How many purple squares are there? And making that connection between the number of squares and the number of cards or number of puppies or objects or dogs or butterflies or however you want to say it. The way that this lesson is structured, when I show this to you, it gives pros and cons for having these two objects be the same or maybe having them different. So, you know, choose whether you want them to be the same or different. So once you've established 2 objects here, 2 purple squares, 3 objects here, 3 orange squares. Once you start getting that connection between these, one of a powerful thing, I'm going to close those. And what I'm going to do is, after I reset the sim and turn all these off, I'm just going to quickly put some objects here and then hide the play area. When I do this, the only thing you see now are the number of squares. I can ask which side has greater. I don't need to ask how many unless you want to, but really this is about connecting the number of squares to each of these sides. So ask, how do you know which side's going to have more? And we say the orange side because it has more squares. That's great. If you wanted to say how many and we count the number of squares, you can also reinforce the one-to-one correspondence. And then you can open these and confirm I have 6 with the number, the 10 frame. And over here I have 4, the number, the 10 frame, and I can reinforce that we have that number of objects. Once you've established a very strong connection between the number of squares and the number of objects, the next part of the lesson, and this is broken into 2 parts, just in case you don't have time to maybe complete the first part of the lesson, is to then switch and say, what's changing and what's staying the same as you switch back and forth. How many squares are there here? How many squares are there here? Do you see anything changing? And what the students will notice is nothing's changing except for the representation in the middle. So once we've established that, we can ask how many puppies are there on the right? How many puppies are there on the left? One thing that you might want to consider is having 5 objects, as that arrow would then line up with a nice number pointing to the 5. Again, you can then reset the sim, or you can, you know, bring them back, or however you want to engage with that. But if you want to do this quickly, you can do something similar. And you can either ask how many objects are there on each side, or you can ask, when I press this button, how many squares are there going to be on the right? How many squares are there going to be on the left? Trying to make that connection that the arrow is pointing to that number. You can also ask how many objects. And of course, once the students really get good at this, you can take them to the teens. And as you take these to the teens, you can see it becomes very overwhelming very quickly as we try to count these squares. This is a very motivating activity for students to then use the vertical number line to say how many. I can either count up from 15 or down from 20 and give them a reason to want to count up from 15 or down from 20. This is a very powerful way that you can leverage this sim. So in this lesson, the main goals are the number of unit squares match the number of objects, highlighting the one-to-one correspondence. It also really highlights the way we can compare numbers, not just by counting the objects and using these numerals of 6 and 5, but also a visual representation of which stack is higher. And that the number line tells us the same thing, perhaps in a little bit more efficient way. Before we move on, are there any questions? Let's see. Is there a way to get the 10 frame to show up on the screen? Do you mean like this? I'm not sure what your question means. Can you elaborate, Brian? Mm-hmm.
I think that maybe he was thinking of that, that button that kind of organizes all of the objects into a 10 frame and
Mhm.
seeing the actual frame.
Got it.
So yeah, so this one doesn't, but yeah, you could maybe show on the lab screen.
Mm-hmm. Here in the lab. Okay. Anything else before we move to the next simulation? So the third simulation we're going to highlight today is called Make a 10. And Make a 10 is different. It's I don't know when it was built. It was built before number play and number compare. And it engages the students in a little bit different way, composing and decomposing numbers within place value. So I'd like for you to play. Amanda put the link in the chat for a few minutes. And as before, please put your discoveries in the chat as you find them. Think about how students might interact with the sim and how the sim might help students learn place value. What might you do with this sim? So play with it for a few moments, please, and feel free to enter your observations in the chat. All right, if you could put some things in the chat that you're noticing. The sim is very different than the others, so I'm sure you'll have some very interesting things to note. Of course, we know this is not enough time for you to get really familiar with the sim, but hopefully at least enough time to get a little glimpse. So a lot of you are noticing that you can compose and decompose numbers pretty flexibly. The way that you compose and decompose numbers is a little bit different in this sim, whereas instead of the handle up here, you notice that the cursor changes. Here it's like a grab me, and as soon as you cross a line, it changes to a hand. That line you can see here because I haven't done it yet. But once you press in that upper half, you can see that the numbers themselves will change to decompose. I don't have to build up. There's not a limit of 20. So I can just bring out 100 and I can decompose 100. But look at what it does. Instead of going 100 and then 99 and 1, it actually decomposes by tens because 100 is 10 tens. So this is an excellent way to reinforce that 8 is not just a digit, not just a numeral 8 just randomly sitting there. It's actually 8 tens. So as you look at this and decompose it, you can reinforce I have 8 tens or 10 tens, which is one of the cool things about this sim. One of the things that is perhaps something you noticed, let's say I want to combine 8 and 4. When I've watched teachers interact with this sim, they will do this and notice that the 8 and 4 repel each other. And I think I've watched teachers do this same thing about 10 times before they realize it's not going to work. They think they're doing something wrong, like, oh, maybe if I put it just above, it's going to work, and it will not. And so one of the powerful things about this sim is, perhaps you noticed this or found out how to actually combine these, is I must make a 10. Once I make a 10, now I can add those numbers together. And perhaps you can see that 0 hanging out behind that 2, so that you can reinforce that it's 10 plus 2 and not just some random 1 sitting out there with 2 added to it. It really reinforces that this 1 is not just a digit 1, but actually 110. So this sim is very powerful when we're talking about creating tens and moving through 10 or moving through powers of 10, etc. So that's one of the things that you probably noticed as well. On the adding screen, you notice you've got these things here which are different. As I press this, I can enter in any addend as long as it's 999 or less. I can't enter 1,000, but I can go up to 999, and the 2 addends show up here. You can see the zeros behind these, and as I decompose these, I can see I've got 9 100s, 9 10s, and 9 1s, and you can decompose and see each of these ones if you like. Will there be future versions of this going to larger multi-digit numbers? Did you see how large, what's the biggest number that you can, are you saying adding more larger numbers than just triple? This one goes to 3. You can add 3 digits. You can create numbers larger than the sum of 999 plus 999. But the biggest addend is 999. So the game, there are lots of games, and and you can see by the icon what kind of game this is. So for example, this game are numbers under 20. This is just 10. Here's under 100 and over 100. So the icons can help you identify what kind of game you're going to find. So for this lesson, oops, this is called the standard adding algorithm demonstration. So this is designed to be a demonstration, but I'm going to give you some opportunities to play around with it with a different problem. So as I said, I'll show you where to find these lessons and more on our website in a little bit. The concepts included in this lesson include adding, the traditional adding algorithm, grouping, regrouping, or composing, decomposing, and of course, flexible thinking. This is a great sim to inspire or to invite students to be thinking about how to add and take away creatively as they compose or decompose. I forgot to mention, but hopefully you noticed that I don't have to see the total. If you wanted to put numbers out here and ask students what number this would make, you can hide the total so it's not just hanging out there. So for this lesson starts, you can enter in any 2-digit numbers that you would like. For the purpose of this webinar, I will be using the numbers suggested in the lesson just so that you can see how that lesson flows. So 687 and 284. You can use any 3-digit numbers that you like, but the goal is to create numbers that will require some carrying. So as I stack these as if I were going to add using the traditional algorithm, the traditional addition algorithm, I can very importantly stress that 687, as I mentioned before, is not just some random digits put together that happen to be next to each other. I've got 7 1s, I've got 8 10s, and I've got 6 100s. Here I have 4 1s, 8 10s, and 2 100s. Now, as we noticed before, I really, you can't do that. And so this is why reinforcing caring is important. If I want to actually combine these, I'm going to have to decompose one of the numbers. It doesn't matter which one, but if I decompose, say, the 4 into 3 and 1, I can leave that 1 down. And now I notice I can combine this 3 and this 7 to make 10. Now it's not in the correct column, if you will, according to the traditional algorithm, because now it's a 10, which means it needs to go over here. So if I try to combine these, again, I cannot. And so I need to find a flexible way to add these 3 sets of 10 together so that it will work. Well, I can put the 10 there, and I can put one of these here, noticing I have 70. And again, now I have 100, which then makes it belong over here. I can combine these, and now I have my hundreds, my tens, and my ones, and I can combine them to create the sum of 971. This really highlights the meaning behind the traditional addition algorithm. We all know as educators that there's a lot of hidden mathematics behind most of the traditional algorithms, and this sim is fantastic to highlight all of the hidden, maybe not all, but maybe all, a lot of the hidden mathematics behind the traditional algorithm. So I'm going to give a different problem, and I ask that you take a moment to see if you can add these together and maybe challenge yourself to find a creative way of solving this addition problem. So the problem I'm going to give you, 390. Perhaps you notice that if I take this 7 away and decompose, I see that 298 is a mere 2 away from 400. And then when I put these together, I can mentally add this to be 655. So perhaps you noticed that that there is a flexible way. So as you have students play around with this, encourage them to find very creative ways to use the sim and reinforce flexible thinking. Thanks for your patience. It's yeah. So in this little lesson for Make It 10, we learned the meaning of carrying and the traditional addition algorithm. We learned how the traditional adding algorithm works and how it can encourage flexible thinking. So in the short time we have left, thanks for your kindness, Sarah. I'm going to show you how you can access these resources and more on our website. So before Amanda puts the link in the chat, I'm going to show you the website if it will load. Amanda might have to share. But the website is free, of course. And when you get here, here's our main site. You see these filter buttons down here. You can either filter by math, or if you go to this tab here, you can filter by math. Back to an earlier question about screen readers and alternative input and other accessibility features, you can also feature here. I can feature by grade level. And here are the inclusive features that we offer. And by filtering, you can see which of our simulations have interactive highlights, interactive description, and so on for screen readers. So this is how you can filter here. So these are filtered default by newest. So our number compare and number play are newer, and our Make It 10 down here is not as new, which is why it's a little bit lower. So if you want to maybe filter by A to Z. So I'm going to show you the number play. When you click on number play or any of the sims, you see this landing page. The first tab is the about. On the about, you will see some topics that this sim covers. You will see some sample learning goals and standards alignment to the Common Core, as well as the inclusive features that are included in this simulation. Here's where you download the sim, and you could get on a student's device and download it for them if they don't have online access at home, or you can embed it maybe, I don't know, in a PowerPoint and have them download that. But you can give them a URL, which is probably a little bit more efficient, and then they can have that URL open at school. This activities page is where you find all the activities. Here's the Family Mr. 10 that we did. And as I mentioned, there's a Word document to modify and customize for your needs, or there's a PDF for very easy access. In order to see these lessons as well as see the other PDF, you will need to create a free account. We encourage students to not create free accounts. We never collect student data. When you give the students the URL, they do not need to sign in ever. We do not collect any student data. So the URL is very accessible. So this is how not all the lessons look the same. This is the family of Mr. 10. Tells you what you need for pre-planning, tells you how the lesson cycle goes, approximately how many minutes it will take to engage with. Oops. Oh, shoot. I shut the thing. Go back there. On the teaching resources page, this is a PDF giving you a screenshot of all of the screens. And the purpose of this document is to make sure, sometimes when you're playing with a sim, you don't find all the features of the functionality. The purpose of this is to ensure that you find them. It also has the instructions on how you can customize each of the sims and some suggestions for use, which include challenge prompts. If you don't want to use a full lesson, then perhaps you just want to ask your students to play, and here's some ideas. I want to show you how you can customize the sim. And for example, these are called query parameters. So if you want to have the sim auto here, these are live links. So if I click this, it will provide the link to the query parameter, but sometimes you want more than one. This question mark says, here's the regular URL, but I want to customize it. When you put that question mark, it says, customize me. And you say customize using auto here. These are case sensitive, but maybe I also want to customize it to only have the students engage with the first two screens, 1 and 2. When I press enter, now you notice the lab and the game are not there. This is the URL that you would put in your learning management system. Canvas, Seesaw, Schoology, Google Classroom, whatever you use, this is the link that you would provide your students, and this is what they would see. So as I want to show you some of the other customized links for, say, number compare. Number compare, as an example, let's say that I didn't want to go all the way to 20. I mentioned earlier that you can customize that vertical number line to have a maximum. Let's say you wanted to have a maximum of, say, 9. Then we have compare max, and then you say, I only want the maximum number to go up to 9. And I want them to only see the first screen. When I do this, you notice that the screens across the bottom no longer appear. I can't click on any of the other screens. And when I do this, notice at 9, the button goes gray. When I press this, the tallest number is 9. So as you customize the sim for whatever number you're working on, you don't always need to go to 20. So each of the sims has a customization option. And in the few minutes that we have left, just to summarize, sims are flexible. You can use them as a demo. You can use them as an interactive activity, inquiry activity that your students can use in a one-to-one setting or maybe shared devices. The simulations inspire students to be creative, collaborative, all on their own. You will not have to prompt them very much for that. They engage and empower students as they learn challenging mathematical concepts. It builds agency and confidence in students as they learn. And the simulations have many entry points where all play is productive play. Just to reinforce, we have very little to no instructions in our simulations. So with that, just want to see if there are any last minute questions. Feel free to raise your hand. You can always email us. Great, that's fantastic. Thanks, Lori. You can always contact myself or Amanda. If you have further questions, you can find us. Here's our website. We're on Twitter, or formerly known as Twitter. We're on Facebook. And if you do create a free account, we encourage you to create a free account. You will get our monthly newsletter for news and publications. And we'll be sending out a link for the recording, as well as a post-webinar survey, as well as a link to all of the links that we did housed all in one place in a Google Doc. So look for that in the next upcoming days. We appreciate your time. Thank you so much for joining us today.